My name is Holden Marceaux, and I'm doing a 6-minute talk on geothermal energy. Just a little bit of background. Heat has been radiating from the center of the Earth for about 4.5 billion years, and this heat can be captured and used to produce electricity. More than 11,700 megawatts of utility-scale geothermal capacity was in operation in 2013, with another 17,000 megawatts planned in the near future. Geothermal facilities produce about approximately 68 billion kilowatt hours of electricity, enough to meet the needs of more than 6 million U.S. homes annually. And you can see it's just kind of a temperature breakdown as you go deeper into the Earth. The primary sources. Heat below the Earth's crust is mostly produced from the decay of radioactive materials. The amount of heat within 33,000 feet of the Earth contains 50,000 times more energy than all the oil and natural gas resources in the world. Geothermal hotspots occur near the boundaries of the tectonic plates you can see from this map, where the majority of the hotspots occur in the United States. Coincidentally, they also occur where a lot of earthquakes can happen at the boundary of plates. The basic method for how it's captured, cold water is pumped down into the Earth. It's allowed to be heated. It's drawn back out. Either steam or hot water. It's run through some form of a Rankine cycle or other power production cycle, and electricity is produced from it. Geothermal plants can be designed to be base load, which means that they produce a constant stream of power, or dispatchable, which means that they can fluctuate with the needs of whatever community they're providing power to. The U.S. Geological Service defines a high-temperature geothermal systems as those of temperatures greater than 302 degrees Fahrenheit. There's 3 basic methods for collecting geothermal power. The first is flash power. Water is drawn up from the Earth, and steam is separated from it using pressure in a steam separator that you can see right here. Steam is delivered to a turbine, and the turbine produces power. Then hot liquid water that is rejected from the turbine is pumped back down into the Earth to help preserve some of the thermal energy from the source. The next method is dry steam, where steam is drawn directly from the Earth. It's run through a turbine and then put back into the Earth. There's no need for a steam separator, and this method accounts for approximately 50% of all of the geothermal energy produced in the U.S., and most of the locations are in California. The third method is what's called binary power. It makes it possible, this is supposed to be 302 degrees Fahrenheit, it makes it possible to use sources less than high energy geothermal site. Basically, the water is pumped out of the Earth and is run through a heat exchanger with another working fluid that has a lower boiling point than water, usually isobutane or pentafluoropropane. The working fluid is then heated up, run through a turbine, and the working fluid stays in the cycle, and the water is pumped back down into the Earth once it's used to heat the working fluid. Another way of using geothermal energy is for heating and cooling of homes. In the winter time, cold water can be pumped down into the Earth, and it can be heated by the Earth and pumped back into the building. In the summertime, hot water can be pumped down into the Earth and cooled by the Earth, and can be looped back into the building. This can be used almost anywhere in the world at depths of 10 to 300 feet, just depending on whether or not you're heating or cooling the water. And they're used in all 50 states and are about 45% more efficient than conventional heating and cooling systems. That's it.